All right, Professor Cooper here with another short video on a couple of geoms this time. Just a couple of random geoms that I'm adding to the mix that are actually maybe not so random in the sense that they're good competitors to some of the things that we've done already. So let's talk about waffle plots, one, and ridgeline plots, two. Normally this week I also do a ternary plot, but honestly it's very rarely useful, especially in things like political science or the social sciences. If you're in the hard sciences and you're doing something that has exactly three categories and adds up to 100%, then maybe we could talk. But generally speaking, those are not very useful for us. They have limited use, so we can talk about it, and I can definitely give you code about that, but I'm not going to worry about it. I'm not going to make you do that in the assignment for this week. So let's do a waffle plot. Let's do a ridgeline plot, and we'll call it a day. All right, so we need an extra library. We need the waffle library, the waffle package. So we'll have to call that. And everything else, it provides the latest version of this. You need to either get install the latest version or maybe go to GitHub and get the latest version. But this works really well. It's a really nice alternative to a pie chart in the sense that it presents the same information, the proportions by category that are represented by each category. What it doesn't do is force a polar coordinate angular perspective like a rose plot or a pie chart, which introduces perceptual issues with the brain and with the eyes. Instead, it keeps everything in a rectangular space, which is much easier for the eyeballs to perceive and the brain to perceive. All right, so you're actually going to set it up just like a pie chart, though, in terms of the data. You're going to want to get to a point where you have categories and you have counts, and then theoretically counts that are converted into percents. And so I'm using the diamonds database. That's a database available in R. I group by cut, and then I do a summarize to get a count, and I'll cut the pipe right here so you can see what that does. So the cut, we should probably take a quick glimpse at the data as well. Well, that's not right. All right. So we have caret, which is, I guess, the weight or the size, color, cut, clarity, depth, table, price, and then three measures of X, Y, and Z, or like individual angular measurements of the actual rock. Okay. All right. So we are grouping by cut. It's an ordered factor. And we are then using this n, and that's going to count because I grouped by cut. When I summarize, it creates a new data table. I call it NN just so it's not N. I might could have called it something else. And it represents the total number of rows that are represented by each of the cuts of the diamonds. So the cuts are ideal, premium, good, and very good. I believe that's it. So at this point, you get this little miniature table that is obviously like summarize. It kicks you out of the original data table, and you're in this new little miniature data table. But we still have the grouping rule set up. So what we need to do real fast is ungroup and then mutate ungroup just releases the rule, basically. And then right in this summary table, I'm going to mutate, and I just make a percent, which is the n divided by sum of n times 100. Easy enough. So I will now cut the pipe so you can see what it looks like at this point. Oop, that's not the appropriate thing. Okay, so you can see I've changed these to percents. And then we're going to go right into ggplot. The arguments for the waffle plot are values and fill. So all you need are how you populate the values. And I'm actually going to take that percent and I'm going to round it. So I round it to the nearest whole numbers. That's what the round function is doing here. There's an argument for how many decimal places, but the default is to a whole number. And then the fill, meaning how is it going to separate by color? It's going to separate by that category. Very good, premium ideal. And then geom waffle, and that's it. So it starts to set up like a pie chart, but then you don't do chord polar, and you have a couple of arguments in the aesthetics, and you're off to the races. And here's what it ends up looking like. These are base R colors at this point. I haven't done anything with the theme, anything. Let's let it stretch out. You can see it's doing the exact same thing that a pie chart does, except it's not forcing perspective through this weird angular polar coordinate. I can easily see when one category has more rectangles than the other in this quote-unquote waffle. So it's a little bit more modern. I like it a lot better. I think most people do. Maybe not people that are business people that use Excel all the time, but I think these are much more appropriate for perception. And you can obviously do some little twist on this where you like separate out the rectangles a little bit, give a little space between them, things like that. But this is the base of the waffle plot, so that's that. It's a good one. All right, now let's do a ridge plot. A ridge plot basically shows you a series of density plots, or maybe histograms, by categories. So it shows you the distribution of a variable that's continuous, but also chopped into categories. And it does so in a way that you can potentially see sort of overlapping distributions, but they're also separated. And I'm going to show you an example. So this also takes a library, a special ggplot additional library called ggridges. And I'm going to do one version. I'm just going to do the density plot version. You can also do a histogram version. It's very easy. The code is trivially different. And it takes an x, which is going to be, the x-axis is actually going to be sort of your dependent variable, so the genie reported in this case. The y is going to be the regional category, so the categorical variable that you're splitting up the density by. Fill is going to be region UN. And all it's going to do is it's going to give each of the density plots, instead of like putting them on one x-axis starting at 0 so they all overlap, it splits them apart a little bit, and you get this sort of mountain range-like look to it that's kind of nice. You lose the y-axis distribution, the proportion of the density at the like peak, for example, but that's not actually super useful information anyway. The shape of the density kernel is actually very useful, but you don't need the y-axis for that. So then I made some labs and I added theme minimal here. So let's run it, see what happens. I used the WID dataset, if you didn't notice. You can see it's got this sort of, because there are 5 of them and there are these base colors in R, it kind of looks like, melted Pac-Man ghost or something like that. But this is a good example of what a ridgeline plot, and you can imagine something with 15 or 20 categories, it would still look good, and it would have this effect, and you'd be able to see, you can still see all the distributions. You can get a sense for where, well, right now I have gotten rid of, let's see, oh, it's still behaving. Yeah, we would want to add, of course, we'd want to add maybe the Gini reported values on the x-axis at least, because this, as it currently sits, looks nice, but it's actually not giving you the information, right? I don't think this is the default, but it might be, I forget. Anyway, it's easy to override it and add the axis back. It's not a big deal. But you can imagine having 10 or 15 of them, and it's actually looking really good. You can see the distributional differences, and you can even add some alpha so that you can see where there's overlap if you want to. So you could do something like this instead. It's not necessary, but it could potentially be useful. Okay, that's the two new plots, the two new types of plots that, in addition to some of the others that are already in one of the other various Geoms videos, these are the new ones for the week. So I hope these make sense, and you can see how they compare to other plots and how they might be very beneficial, especially the waffle versus the pie chart. All right, thanks.